Hello, this is Mark van Berkel coming to you through a video on entity resolution, and I'm sad to not be at the DCA conference this year, but unfortunately I wasn't able to make it. I have a couple topics that I did want to share, even though I haven't been able to make it there. One is on entity resolution, and another one is on constraint management. And I was suggested by James for me to just do a recording, and here is my recording. So I'll go into presentation mode, and if you have any questions or comments, you can send me an email or reach out to me after the fact. Be happy to talk about this. And with that, I'm just going to jump in because I know you're probably all eager to have a discussion, and there's probably others to help facilitate this topic area of DCA. And let me go ahead here. So, just quick about me. So I'm a co-founder and the COO at Schema App, and I am not a vendor selling anything. I'm actually quite interested in using semantic technologies to build our own company. And so, as way of background, myself, I started as a software developer consultant and quickly got into SAP software. And so, in the um, early 2000s, I started my career in 2002, and then I started working with SAP software 2003. And you could see these complicated systems. And so, when Dave McComb talks about the sprawl and all of the kind of the complexities of these large IT systems, I've seen some of that firsthand. And in some of my work as a consultant, was able to try to do some more model-driven things to help accelerate things that could be configurable and generalizable. And in one project in particular, we were working through payroll information extraction type of software. So this was a SAP human resources module. We were rolling out like in many countries for a telecommunications company, and each of them needed payroll information extracted to be able to satisfy some local payroll providers. And we just when I came into the project, there was these long cycles of doing some development work, and we were able to use an approach of trying to generalize the concepts in this payroll information extract and put them into a table, and was able to spend a little bit longer on one of the cycles in which where when I started for the next rollout for countries, and was able to we probably spent an extra 2 3 weeks. And but what we were able to do is to create this model driven approach. And then on the next sprint of 5 to 10 countries, we were done in a matter of 2 days or 3 days. And it really kind of drove home this kind of this concept of being model driven. And so I've been really fascinated with trying to like look for these kinds of points of leverage ever since. We started Schema App in 2012, tried and failed a couple different concepts, and personally started looking at just the ontology since 2013 and version 6.7. And in 2013, we launched what was the precursor to Schema App to scratch an itch in schema.org projects. And so in 2016, we switched to dedicate our focus on Schema App. And we are an enterprise schema.org solutions company. We have clients such as SAP, Advent Health, Sonova, Upwork, among a few of them. And we have 28 employees. I myself have attended 3 DCA workshops, 2 in person and 1 last year virtually. And I'm interested in intelligence-driven development, as I mentioned, simple designs and extensible architectures. I'm excited for the potential of the data-centric architecture and the vision for the best aspects of semantic technology for our back office solutions. So we use GIST, as I mentioned, to help manage our back office, so our obligations, the contracts, contract terms, different products and service specifications. A lot of that stuff. We have events. We have a whole bunch of different kind of concepts that we use for our own systems, and we continue to use. So now onto entity resolution. So in a perfect world, um, all entities are created equal, and you don't really need to do entity recognition. You just everything's created as one and the same. But as you know, that's probably not the case. Open source might be a plug and play solution for entity resolution. That would be great if there was an open source solution that you could just plug into your stack. Failing that, if there was a commercial off the shelf plug and play solution for entity resolution, that would also be great. Failing that, like if the question is, maybe all entities could go through the same creation pipeline. They all come through the same data pipeline, and then they would all be created equally, and that would be great, right? And it would be great if all the entities had the same type of identifiers. That would be super helpful if we were trying to lock things together and trying to resolve different types of concepts. And failing that, like, it would be great if then all entities use the same labels, and like the labels don't have um, like suffixes and prefixes and maybe or even in the same language. Like it would be great if all the same labels were correct, right? And then it would, in a perfect world, all entities have the same structure. Maybe they're sometimes they're kind of the data model's just a bit off, and things like maybe there's a one-to-many relationship, and sometimes those don't exist in another concept, in another knowledge graph. And in the perfect world, maybe all entities are semantically similar, like they're actually meaning the same. Like that person, like is. I think there was an example from Mike Oswald Brown, Mickey Mouse. Like these fictional characters aren't always the same. And anyway, there's semantic similarity you would hope, but in the real world, probably none of these things are available to you. So like it's a complicated problem. It's a real problem, and we do have to solve for a lot of these challenges. And what follows, I've got some approach for what kind of is the basics, and then I'll go into some other ideas for entity resolution with more complicated kind of problems. So with that, let's keep going. Um, I think it's first worth noting that I think entity resolution is at first actually just a data identity failure. Like we've like with if you've identified the things up front, if you have a kind of a common URI minting scheme, your data identity should actually guide the resolution through within the knowledge graph in the RDF world. You can use a URI minting scheme as the number one way to solve have entity resolution. Uh, and it's when those subjects and objects with the same URI have the same minting, like where it's maybe the same type, the same base URI and identifiers, they actually start to snap together across your data set. So objects can be referred to, and the subjects in another triple, they can come from two or many sources, and you basically get this data integration for free, which mitigates the need for the entity resolution in the first step. So if you are able to figure out your URI minting scheme before the data comes in, and in a way that is consistent across different data sources. You start to resolve your entities even before they get into a knowledge graph, and that is I think priority number one, because you can avoid problems before they begin by trying to address it first with a consistent URI minting scheme. The next sort of approach, so a bit of pseudo gist ontology here. What I really like about the gist ID concept is that it's just simple, it's easy to use, and it's flexible, and it's something you can use, as you'll see, to start to reconcile the different entities across different sources. And so an ID is the definition content that is used to uniquely identify something or someone. Excuse me. It's an intersection of content is allocated by intellectual property. It's or an organization or a person. and it has a unique text of a string. So what you normally see is perhaps an organization is identified by some gist ID, and that gist ID is allocated maybe by a department, by a third party kind of data provider, and it has a unique identifier with just some scheme of its that it's come up with. And so what you can do then, by taking a gist ID, is whenever as things come into the system, I think that's coming in. You can leverage the gist IDs in the data loading for an entity identity reconciliation. So during data loading, apply the gist IDs from that source, and those things, if they exist in the database, you can use that while like the data is coming in. And so the data loading process, if you generate RDF data from a source system, uh, we use RML predominantly, and it's like R2 RML, but it also includes JSON structures, which we wanted to have for a lot of the web APIs and webhooks that we use. And so as we generate RDF data, we're also creating these gist IDs for almost all the objects that we can. And those might be, if it's for Stripe as the allocated by, Stripe has a scheme of just unique texts. And so we put those in as a pair, and we attach that to the objects. With that kind of data that's come in and mapped, we then can cross-reference those gist IDs of the map data with the pre-existing gist IDs in the database. And with that, so we kind of, before we load in the map data, we pull in the gist IDs that exist in the database with the subjects with the IDs, and we can cross-reference to see if there's any matches. And we look for subjects with the same combination of unique text and allocated by. And then for the map data, we can replace the URIs that we've generated with the URIs that were in the database, that were fetched from Neptune in our case. So, and with that, then like the data that's in memory before we persist it, we replace the URIs in that RDF, and then we then store that map data with the resolved URIs. So it kind of has a simple approach. Here's just a diagram to help uh, illustrate it. And so here you can see this is all in our AWS environment. Oops. So at the start, there's an event bridge event, and says, so there's something that's come in, there's some data that we want to map. So we produce from the S3 object, we'll produce mapped RML, and then that mapped RML will generate URIs for the source information. And if there is any gist IDs in that mapped uh, data block, then yes, we're going to proceed and try to do some entity resolution. So again, we're pulling in data from Neptune, we're doing a match with the unique text and is allocated by, and then we can rewrite the entity URIs in memory, and then we continue and add the data provenance and persist it to the database. So this is it's like logistically anyway, it's a pretty simple approach. And what I like with that is that even if you have old identifiers or old URI schemes that don't line up with maybe your current minting pattern, if the object exists already and you've tagged it with a unique ID already, this will like automatically shift and resolve to the correct subject URIs and object URIs in the database. And yeah, so that's probably step 2. Um, However, so that's good for some problems, but not so good for all problems. So let's keep going. As we were coming up with a solution, we thought, great, we're on our way. However, not all entities are created the same. So the different there are lots of different identifiers. And if we're talking about, even in this case, we have the example where we're trying to reconcile and resolve an entity from multiple different source graphs, multiple different sources of information. And so in our project that we're working on, it is a project for customer insights. And so we're actually pulling in information from GitHub, from Teamwork, Freshdesk, Google Workspace, and even our internal administration tools. We have these different identifiers from the different source systems, and if we don't have the IDs defined in advance, what's going to happen is these identifiers are actually all represent the same person, Ross. And so Ross is a person, an employee at Schema App with multiple different identifiers. And if we don't create these gist IDs in advance, they're all going to come in and we're going to get 5 different persons, one for each source system, even though this should be the same singular person. So therefore, we need to be able to reconcile the creation of multiple persons through a combination of approaches. So this is the situation. Like, we're not going to catch all of these things in advance. The first 2 approaches I had given are great if you can plan everything in advance, but sometimes, data comes in and you don't expect it. So it's a pretty typical problem to be able to do it. Also, be able to address these things after the fact, or perhaps in another prediction way. This is further describing the situation. So even if we have a person, and that person is identified by a unique text such as this in GitHub, or by this in Freshdesk, we have other services that would identify them. And the challenge is that with these other these other URIs, we gotta link these up. And so there's a data from mapping from GitHub and from Freshdesk, and you can just see, like, there's no, like, those 2 things aren't going to line up. So we have to figure out how to connect these 2 IDs to the same person, and that's hard. um, when we thought about this problem, what are the requirements? Well, we need to what behaviors do we need to support in such a solution? The problem does exist for other common concepts, especially companies, and assume it's applicable to all of our concepts. So it's not just a problem of persons, definitely a problem also with companies and customers potentially, or contacts. Um, but, like, why just stop there? I assume that there's probably some representation of an entity in more than one place. And so let's just assume all concepts may have this problem, or we may have to design for that. Secondly, we must provide a means of reconciling the subject in the system. So there needs to be a screen or an interface or a method in which the operator or the subject matter expert can go in and identify these things and say, like, these things are similar, or add those IDs and then reprocess. So we need a way of an operator to curate those objects. It is not enough to try and prevent these from occurring. And as much as we might try with the URI scheme, and we might deal with those gist IDs, it's probably not enough. Like, kind of assume the worst is going to happen, and that we need some methods of working around this. And assume also that they will happen, and we can solve them reactively through curation. So a couple of ideas for solutions in this kind of scenario. One, of course, is the preventative IDs. So this, as we create objects in the third-party systems, an operator manually updates the person's gist ID in the editor for us, and these objects will then merge using the entity resolution service from the outset. So assuming you can do it, like, an operator might, before we add a new source, we would want to create these IDs in advance. Obviously, that would be ideal if you could identify that. Secondly, we want to be able to manually merge duplicates. So an administrator viewing teamwork in the admin system should be able to merge duplicates. For Ruby, I've put here as two different objects. So we need to be able to have some sort of change URI button in the admin, and that prompts you to enter the other one. And a version of this, a better version of this could be to allow for a search for other URIs if you actually don't know the URI yet. So I have an example from another system that I'll show you about manually merging. The third kind of solution, which I think is really one that scales better, and that is a job which could be executed to predict potential duplicates for a merge. And any merge is accepted to use the same microservice as one, and maybe a use case for subject prediction. If you were inclined to use machine learning, this would be a good place for it. And a simple similarity measure to a Jaccard score is something you could do also to try to generate suggested duplicates. Another one, perhaps there's different kind of semantic similarity methods. Silk AI has some service, and that can help to find the same as links between the same organizations, as an example. And then automatic approaches cannot help in automatically matching. And so there's definitely still situations where you'll need an expert to able to identify those things. And yeah, so here is an example of an interface from Pipedrive that we have. And so you can see it's just said, when you're looking at an entity in this system, it says 3 duplicates found. And so I happen to put myself in the CRM quite a few times to test different services and integrations. So there's 3 duplicate Mark van Berkels. And if I were to click through on that, this is an interface that Pipedrive provides and says, here's Mark van Berkel 1, 2, and 3, and some different metadata on that, and it just has this preview and this merging option from within the interface. So that's actually about it on the entity resolution. And I do think like some simpler things are better if we can use entity resolution by a minting scheme. Maybe you can avoid a lot of entity resolution problems. If you can use this kind of gist ID, you can also avoid a lot of downstream problems. So earlier in the design, of course, and the data integration cycle would be the better. And failing that, we do need to get into these other types of workarounds and curating and suggesting of your entities. Thank you. All right, so I'm going to go right into the constraint management section of my presentation, and so this is sort of a separate topic, and hopefully we've been able to draw a pointer here to the second topic area for the DCA conference. And as mentioned earlier, I'm Mark van Berkel, co-founder and CEO of Schema App. And if you have any questions about constraint management, I'd be delighted to talk about it. And hopefully we can connect with, here's my email address and my Twitter handle. So on constraint management, this was the sort of high-level topics that were suggested for the conference: back-end validation, front-end validation, sensible defaults. And at Schema App, we use predominantly SHACL. And so I have in the past worked with SPIN, so the Sparkle inferencing notation for constraints. And a couple years ago, we switched to SHACL, so the shapes constraint language. And so SHACL is one of these standards, which or industry kind of de facto standard, let's say. But there is checks, and I don't know much about checks. I mean, I've read some of the things. I've read part of this book, and I realize it has nice, concise rules to define the grammar, and and there's likely great reasons to use checks. I personally just prefer SHACL with no real. I don't think there's any real rhyme or reason. I do like the idea that it's W3C recommendation, so maybe it would be supported longer into the future. I'm not really sure, but I am knowledgeable and follow the knowledgeable about and follow the top quadrant solutions over the years. So where they were putting their emphasis into the SHACL recommendation, I was keen to try to learn about that first and foremost. So um, if you like checks, I'm sure it's a suitable solution, and I don't really care that much. But I do like to solve problems, so what I would like to get into is some of the shape libraries, even for SHACL, and kind of what I put here. This is like one of the original diagrams from the top quadrant folks, and so SHACL core is the main thing that's actually gone into the W3C specification, and that's all the light blue. So SHACL shapes declare targets. They declare constraints that have type of, oops, sorry, have the type of constraint components. And there's core constraint components that cover, like there is a compact syntax, and within the rules side here, within so SHACL shapes has rules with triple rules, node expressions, and functions that are available in advanced features. So there was a sort of there was what was actually accepted into the specification. There is then a bunch of other stuff that's available, and at our company, we use SHACL Core like 90%. Like we're solving our problems just with the SHACL Core specification. We use Sparkle occasionally. It's kind of something we try to avoid if we can because of its impact on performance, because it has to query over the whole graph. And then we put advanced features. So we're doing more in rules and more on this end of the spectrum, but on the SHACL JS, it's been phased out, evidently. So um, I'm not sure how that future is going to go, but we haven't used it before, and I did see some evidence of that in the documentation. So front end validation, we've used the I've personally used the JavaScript SHACL library from top quadrant, and so you've got the SHACL playground, and it as a library points to the Zazuku RDF validate SHACL service. They both work pretty good, and I would say that for mocking up scenarios, for developing some unit tests, for developing iterating on, like as a developer, like these are quite good for you to experience, and they're pretty effective. So here's an example of the SHACL playground, and you can see here over the shape, the node shapes and stuff as an example with a data graph. And you can put in different types of content. You can obviously have turtle and JSON LD, and you get a validation report, and things show up pretty fast, and it's consistent. And I found it to be quite useful, and I still use it. However, right at the top, it says that it's written in JavaScript in the Zazuko SHACL playground for a newer implementation. It's just another option. I'm not sure that it holds that much benefit. Like it has a couple of other options around your prefixes, and so you can use this as well. We've used you can see here I've got a schema model and use different prefixes and such to test different things. So from a developer point of view, or if you're just looking as the modeler, these are quite good, and I don't think you'll have too much challenge with them until you start getting to a big size. And that's where we started using other tools, actually, is when the graph started to get too big, and things start to slow down, and I'll get to that. I'll come back to that. So um, both of these, the Zuko doesn't support SHACL Sparkle constraints, which would make sense. Like it needs to have access to your graph databases, and they drop support for the SHACL JS extension and adapt the API to suit their needs. So that's part of the pointer I was highlighting in the last slide of the JavaScript extension is being dropped in support. So on this slide, you can see that the input graph has all of these objects, and the scope selects the focus nodes. So SHACL has a way of targeting which nodes are going to be tested. And then there's some filter that eliminates some of the focus nodes, and the constraints produce some validation results. This is a sort of like basic kind of process for for SHACL and for the validation. And the performance of the SHACL depends on a few things that we learn. So JavaScript didn't handle large amounts of data and shape. So um, if you have a large data set or even a large graph of shapes, and you're going to start running into performance problems. And we had, as I mentioned down here, for production, we wanted more performance solution for larger shapes graph with about 8,000 triples. And so when we were testing things in our front end application, it was too slow. And so we had to always continue. I think we had to continue to reload those shapes, and just the parsing part of it took a while to get those into the JavaScript library so that you can run your data through. Um, and what else? So what I've said here here is that the JavaScript is good for development or lightweight use cases. And so if if you're able to modularize maybe your shapes graph with not having a ton of data like to validate, like kind of have more distributed, if you will, um, constraints as well as data, then I think this could still work for you in production. And it kind of depends on the use case, and there's probably counterexamples to this, but for us we started running against this performance problem, and so we went to a back-end solution. So what we do want to have for us, we want to have a scalable API and an architecture that allows for like a 1 second response time, because we're looking for this to come back for the user. And we want a cloud hosted version of the SHACL API in Java that's based on the Apache Jena. We want our service to preload the shapes graphs. As I mentioned, we have like 8,000 lines of just for one shapes graph for our schema.org ontology. We want to preload that so that it's already in memory and ready to just apply against the data as it comes in. And the data for us, we're posting data graphs to be validated, and we're just returning a validation report. Hope that makes sense. What we've created, we've called Boom Shaka Lambda, which is just a play on words from NBA Jam from the 90s. It was a boom shakalaka. It's just silly kind of naming, but anyway, what we've created here is it's a Lambda. So in the AWS environment, a Lambda is a function as a service. So basically, you have Java, and the Java runs as needed. You don't pay for when it's not used or not called, but you pay for basically the every 100 microseconds or milliseconds rather, and it's always available. And so for us, we have from our client environments, we're taking the data and we can take it through Turtle or N-triples or JSON-LD, pass it through an API gateway, and that RDF is brought into the SHACL Lambda. At the same time, the SHACL rules graph is preloaded, which is, again, as I mentioned, it's important. and then that outputs a SHACL violations graph. Um, our integrity constraints in SHACL it's a kind of a progression. So even though we have our SHACL for available for our applications, um, there's this progression from the open world to closed SHACL, and so one step at a time, though, because we didn't have the luxury of having all of our SHACL in place and closed a closed SHACL shapes at the outset. So we've had to kind of continually do an iterative approach to kind of get closer and closer to high quality graph, essentially. So the open world, this is a data model of business concepts. Anything can be loaded. So like in RDF, like you can put schemaless RDF into your system and then try to explore it with different tools and different methods. Um, that's great for some scenarios, depending on your situation and on the application. However, the data shapes, so you define shapes for the data model with SHACL in this case, and with those shapes, then you can then begin to review and apply to your existing data to conform to the data model. And this is a big step. So this data review cleanup, we continue to do this, and we're just kind of picking off concept by concept essentially. So one day it might be an obligation, next time might be persons, and it's just each object we try to get closer and closer, and we do some of this step. And once you have an object that is conforming to your data model and to your shapes graph, you can then actually mark them as closed. So there's a SHACL close true Boolean that you could set, and when those shapes are closed, you can change in the front end. I saw a nice presentation from the from top quadrant where in their EDG system they had an environment where they were just when they hit save, it would give a warning to the user to say that the the data does not comply and that there was an error, and like, do you want to save anyway? And so like you could perhaps allow for users to override it, to allow it, but um, I would imagine as when you close your SHACL, you're disallowing any of the bad data to get back in, and this isn't an incremental um, kind of iterative process. All right. Um, so I do have a demo, but it's nothing really to write home about. So you would post. This was a URL that was given to us for Lambda and for executing through the API gateway, and we could accept those kinds of things with different headers and different content types and validation graphs. And we have a bunch of the like I was going to show, but I think I'm going to skip. But we run it lots. It works well, and it was maybe a couple of lessons learned here. So in the Java Lambda runtime, to avoid a long startup, Lambdas need to be kept warm. And so like sometimes you have like, you can just put a pulse, like almost like every minute, just to run it with a quick thing to keep it warm. And because the startup and the execution needs to load the execution context for the objects every time it was called. And so there's a link here to an article that talks about AWS Lambda for Java developers and talking about preloading those shapes graphs with a singleton. And so that can help you still get like a 1 second response time unless it's the very first time when you load up a Lambda and it's not warm yet. Class reuse shapes. So one of the I really think this is an undervalued part of SHACL, and so inheriting shapes with different methods. So you can combine a node shape such as a sole product is a node shape that combines both the product and some other stuff. it would combine this node shape of the product. This is another way of doing this is with subclassing. And so if you have the product has this definition, the sold product can be defined as a subclass of that product, and it would then with the class hierarchy, you can then actually apply the same shapes and of those parent classes. And this is an essential part for how we do it, especially with schema.org. There's a really big tree of classes, and so we use that for inheriting, and the same is true for properties, in fact. So um, one of the things we came across was the need to post process. So there wasn't a built-in capability or facility to overcome this, and so SHACL can be extended, like the at least I should say the RDF definition of SHACL can be like you can put any triples on a shape. And so one of the things we ended up coming up with was updated and endemic to, and we have some other links so we can kind of point things out to users, and some metadata about the shape, even like when it was created and that sort of thing. Um, so the problem that we had faced was a schema.org contact point is a superclass of a postal address. So that's okay, fine on its own. And then Google, though, recommends properties of a contact point that aren't to be applied to a postal address. And so in this example, so contact point is a property shape that path is on the area served, and it's a recommended field. So Schema app recommends area served for the contact point. But given that it's a set, the contact point is a superclass or a parent class of the postal address, an area served error would show up for a postal address. And so our solution for this was creating this endemic to. So way before the COVID epidemic, we started talking about an endemic to property, which is just a way for us to call out that a particular shape is only specific to that class and not to its subtypes. And so what we've done, we have the Java code after it runs on the graph from the Boom SHACL Lambda. We then will look for and inspect whether or not there is an endemic to on the responses of the validation report, and if there are, then we would filter out any of those constraint violations for those subtypes. So this is just another example of what we've used in SHACL, and the sort of like post-processing kind of thing that's not built into it, but like you can still run that pretty quickly in that Java code in memory. Another thing just to maybe mention is, again, the same contact point. We use a lot of SHACL-driven forms, and we use it for both our admin side of things with their ontology, and then also with the schema.org. And schema.org does different things with their, like, as kind of a different way of modeling things. They don't use RDFS domain and range. They use a schema.org definition, and whatever, that's okay. It's sort of RDF underneath, and it's pretty close. So what we use in both sort of applications, we have these SHACL driven forms, and so there's just this beautiful kind of synergy of like using SHACL for your error validation on all of your concepts, but also using that to dynamically generate our forms as we do, is really helpful. So this contact point area served is a field set recommended, and schema recommends. So these groups and orders can be applied to help you put a property into a field group that maybe has a section of a certain kind, and like perhaps you're doing a street address kind of group of properties. You could have the street address show up above the address and above the city and that sort of thing. And then properties outside the expected shape, we actually call it orphan properties, and we need them either to be analyzed and or removed from the model eventually. Yeah, the dash forms from Holgren, that top quadrant goes further into this topic, and it's just something we would encourage. Sensible defaults. So as far as I'm concerned, like development and testing, use those online SHACL sandboxes from Top Quadrant or Zuzuko. And for us, we found that the cloud-hosted solutions, we needed to have a scalable backend API, and we use it from a whole bunch of different systems. So it's actually something not just for the front end, for that editor, for our users, but like we use it for half a dozen different systems. And but it's nice just as one kind of functional library. um, for the largest data sets, though, I'm not exactly sure. So, like, when we're talking about really large data graphs, lambdas are all done in memory. So you can get up to 10 gigabytes of memory in a lambda, and that's pretty good. We haven't solved for something so big yet, and so you could do a variable size lambda. So, like maybe as a you could spin up a second kind of lambda that maybe has a larger memory and a bigger compute size. That's quite a possibility. And then other options, though, at a larger scale, there's perhaps if you're on a database provider like a Lego Graph or OntoText, like they have SHACL built in, and so you might be able to have more tractable solutions for these larger graphs with a database that supports that. We've thought about running Java with like Hadoop in a MapReduce, sort of like fanning it out over multiple nodes. However, those interconnected nodes have to split like the data at some point, and the data that's split across that may be interdependent could fail. So I'm not sure exactly how you could reconcile that. Um, and then perhaps there is a strategy for sharding the data in smaller logical data sets, like maybe there's just a focus node. And I've talked to a database provider about this before, and if you just focus on maybe just a customer or a product or a contract, and you can pull out like its data, then you could run that through a smaller kind of function and run maybe like 100 of these at a time, like through to kind of get some parallelization, and then you could finally get through a larger data set. Perhaps you need to just shard by graphs. Maybe that would be tractable for you, or shard by just a class and more of another vertical slice. And so there's different ways in which I've thought about solving it, but so far we've gotten away with running it through just our Lambda. So that's it for me. I'm hoping this helped somebody somewhere, and I greatly appreciate the opportunity to present to the folks at the DCA conference, and hopefully I'll see you all there at some other point in the future. Thank you again, Mark van Berkel from Schema App, and have a great day.